Hello, today we will be discussing isotopes, reason behind chemical activity of an atom and valency. Now, if you go through the previous video, you will be finding we have discussed the valence shell and valence electrons. Now, what is the valence shell? The outermost shell of an atom is called its valence shell, and the electrons present in the valence shell is called valence electron. If you see hydrogen is having only one valence electron and it is in the K shell. Similarly, carbon has 4 valence electrons in the valence shell, so it has 4 valence electrons. So if you go for carbon, so the carbon total electron is equal to 6, its electronic configuration is 2. This is K shell, this is L shell, so this is the valence shell. So the chemical properties of the elements are decided by these valence electrons. So who are this? Here in case of carbon it is 4 and in case of hydrogen it is only 1. Since they are the ones which take part in the chemical reaction. So the valence electrons only take part in the chemical reaction. The elements with the same number of electrons in the valence shell will show the similar properties. Those with different number of valence electrons will show the different chemical properties. These points you will be understanding when you will be going through the periodic table. Now, elements which have valence electrons 1, 2 or 3 are called the metals, except hydrogen and helium. Hydrogen is not a metal, but it shows a metal-like behavior, and helium is the rare gas or inert gas. So these elements can lose electrons to form ions. Like who lose electrons? The elements which are having the valence electrons like 1 or 2 or 3. So these are generally losing electron and give the positively charged ions which are called cations. So what is ion? Ion is an electrically charged atom or group of atoms formed by loss or gain of electrons. Now what is this atom? You know that an ion which is positive, it is called cation. Let's say sodium ion, potassium ion, magnesium ion, calcium ion. And if you say about group of ion with positive charge, let's say ammonium, NH4 plus. And what are the anions? Anions are chloride ion, oxide ion, all these are anions, and the group of ions having negative charge are carbonate, CO3 2 minus, sulfate, SO4 2 minus, bicarbonate, bisulfate, bisulfite, all this. These are many more. You already had gone through such ions in previous lectures. Now this is shown. If you see the sodium one, sodium it is having 2, 8, 1 in its K, L and M shell. In case of sodium ion, it loses 1 electron from its M shell and 2 and 8 electrons are in K shell. So you can see here, first one is your K shell, second one is your L shell, third one is your M shell. Now once it loses 1 electron, then you have only K shell and L shell. Now inside it is written how many protons and how many neutrons. There is no change in the proton number, only the change in the electron number. How it will be? In case of this, proton is equal to 11. I'll just go through proton. Electron is equal to 11. You know, for getting electrically neutral, you should have proton is equal to electron. Here, proton is equal to 11 and electron is equal to 10 because it already lost 1 electron. So this is Na and this is Na plus. Now which generally chlorine which are generally negative charged, these are called anions. And now metals are very good reducing agent and chlorines are very good oxidizing agent. Anions are very good oxidizing agent. Elements with 4, 5 or 6 or 7. Elements with 4, 5, 6 or 7 electrons in their valence shell are called non-metals. Metals are very good reducing agent and non-metals are very good oxidizing agent. So the elements which this gain electron. Now you case of chlorine, you can see 287, that is KLM. One electron is gained by chlorine, so you get KLM as 288. You can see the last orbital got filled. So these are negatively charged and are called anions. So they are very good oxidizing agent. So now elements with the valence shell having 8 electrons. Like in case of chlorine, you can see the valence shell is having 8 electrons. In case of sodium, you have seen the valence shell is having again 8 electrons. In case of sodium ion, in case of chloride ion also, you can see the valence shell is having 8 electrons. So the elements with the valence shell having 8 electrons and helium with 2 electrons cannot gain or lose electrons. So they are chemically inactive and are called inert gases or noble gases. Now here chlorine and chloride and sodium, they got the inert gas structure after losing or gaining of the electron. Slowly we'll go into the depth of it. So the valency of an element is the combining capacity of that element with other elements and is equal to the number of electrons that took part in the chemical reaction. So in case of sodium, 1 electron took part in the chemical reaction because sodium lost an electron. In case of chlorine, 1 electron took part in the chemical reaction because it gained 1 electron. So the valency of sodium is 1, valency of chlorine is 1. You can say plus 1 and you can, in case of sodium, in case of chlorine you can say minus 1 because it is gaining. Now here it is given a chart. If you have valence electrons 1, 2, 3, 4, 5, 6, 7, 8. The valencies I generally say this way 1, 2, 3, 4, 3, 2, 1, 0. What happens till 4? The valencies is same like the valence electron. From valence when valence electron is 5, 6, 7 and 8, the valency will be 3, 2, 1, 0. What you have to do? You have to do 8 minus the number of valence electrons. Why this is 8? Because everybody has to, every atom has to occupy the follow the octet rule. That is, they should have 8 electrons in the valence shell to become stable. So that's why you have to do this subtraction from 8 and get the valency. So you just remember this table. Then what is the reason for chemical activity of an atom? Atoms of all noble gases except helium, they have 8 electrons in their outermost shell. You can see that. Mostly the inert gases configuration is shown over here. You can see all the valence electrons, valence shells are having 8 electrons. Now this arrangement is known as octet rule or octet. Now among these elements, only 6 inert gases, which are also called noble or rare gases, namely helium, neon, argon, krypton, xenon and radon, these are non-reactive or inert. They do not combine with other atoms or among themselves to form the molecules. You can see these are monoatomic. So since their outermost orbital or outermost shells are already filled, so their combining capacity or valency is 0. That we had already shown in the previous slide. Helium, it has 2 electrons in its valence shell or the K shell. This can occupy only a maximum of 2 electrons as per your octet rule or 2n square rule, that is 2n square. Sorry, 2n square rule, not octet rule. So according to the 2n square rule, it occupies maximum 2 electrons. So it is now stable. So even though the 8 electron rule does not apply in this case. So there are 2 rules then. One is octet rule, that is 8 electron rule. Another is duplet rule, which is applicable for hydrogen. that is duplet rule is 2 electron rule. So the chemical reactivity of an atom depends on the number of electrons in the valence shell of an atom. So chemically active atoms have an incomplete octet. So less than 8 electrons, or incomplete duplet, less than 2 electrons in case of hydrogen only in their valence shell, and the valence electrons of atoms contribute to the formation of the molecules. Why do atoms combine? There is a theory put forward by Kossel and Lewis in 1916. Independently, they put forward the octet theory of valency or the electronic theory of valency. According to them, the rare gases or the inert gases have stable electronic configuration. Now, atoms of all elements other than the inert gases combine because they have incomplete valence shell. We have seen the two examples of sodium and chlorine, and they tend to attain a stable configuration. Elements tend to combine with one another to attain the stable configuration of the nearest inert gas. This will talk in details when we will be discussing the chemical bonding as well as the periodic table. So they should have 8 electrons in their valence shell. In case of sodium, you will see sodium has attained the configuration of the nearest noble gas, that is neon, and chlorine has attained the stable configuration of nearest noble gas, that is argon. So this is called octet rule. In case of helium, the valence shell has 2 electrons. So this is known as the duplet rule. So hydrogen will follow the duplet rule. So this is achieved either by gaining or losing electrons or sharing the electrons with other atoms of the same element or another element. So the number of electrons gained, lost or shared to attain the octet in the outermost shell is the combining capacity of the element, that is valency. As a result of redistribution of electrons, a force of attraction develops between the atoms. Now by this time you might have understood how sodium chloride is formed. This binds them together to form a molecule. So this force is known as chemical bond. So the chemical bond is defined as the force of attraction between the two atoms that binds them together as a unit called molecule. Now we'll come to isotopes. So what is isotope? We had already discussed in the previous video. Here we'll be discussing only the properties and the uses. Isotopes are defined as atoms of the same element having the same atomic number but different mass numbers. So here the examples are given. For hydrogen there are 3 isotopes. For carbon there are 3 isotopes. Chlorine 2 isotopes. Oxygen also 2 isotopes, and potassium 2 isotopes. So these isotopes vary only in their neutron number. If you see, the mass numbers are different but atomic numbers are same. So where is the variation? In the neutron. So the properties of isotopes. First property is isotopes have similar chemical properties because chemical properties are determined by the electronic configuration of an atom. Isotopes have same atomic number, that is same number of electrons and protons. So you have same electronic configuration. Now chemical properties generally are determined by the electronic configuration of the atom. So the isotopes of an element are chemically alike. You have seen that the chlorine atom of mass number 17 undergoes the same reactions as that of the chlorine of mass number of 35. Second point is, isotopes differ in few physical properties like density, boiling point, etc. Physical constants or physical properties generally dependent on the atomic mass or mass number, and isotopes have different mass numbers due to the difference in number of neutrons. So there is the difference in number of neutrons. So due to that, so the boiling point of protium. What is protium? Protium is hydrogen 1,1. Boiling point of protium is 20.38 Kelvin, and that of deuterium. What is deuterium? Deuterium is hydrogen 2,1. This we had discussed in the previous video. That is 23.5. So you can see the boiling point of deuterium, which has more mass number, has more boiling point. So higher the mass of the isotope of an element, higher is the boiling point. Then isotopes like tritium. Who is tritium? Tritium is H31. So isotopes like tritium and carbon 14. What is carbon 14? It is carbon 14,6. These illustrate the difference in physical properties that can occur between the isotopes as they are radioactive. There are the extra neutron in the nucleus, which is responsible for emitting certain type of radiation. So those carbon 14 and tritium are known as radioisotopes. So the spontaneous decay of unstable radioisotopes is known as radioactivity. Now fractional atomic masses, this also we had discussed in the previous video. Fractional atomic masses, isotopes having like chlorine. It is chlorine is atomic mass is 35.5. The reason for fractional atomic mass is that atomic mass of the element represents the weighted average of all the naturally occurring isotopes of that element. So you can find it very easily. Chlorine 35Cl and chlorine 37Cl are present in the sample of chlorine as 75% and 25%. So if you do the calculation, you will be getting the atomic mass of chlorine as 35.5. Now what are the uses of isotopes? Isotope of cobalt 60 is used for radiotherapy for treating cancer and other diseases. Carbon 14 is used for determining the age of historical and geological materials. Isotope of uranium Isotope of uranium-235 is used as fuel in nuclear reactor. Iodine-131 is used for goiter treatment. Some isotopes are used in industries for detecting the leakage of underground pipelines, gas pipelines and water pipes. Now, there is a question in the previous chapter that draw the orbital diagram of Ca plus 2 4020 ion and state the number of 3 fundamental particles present in it. Diagram you can draw very easily. In case of calcium only, not ion, it is 40-20, proton is 20, electron is 20, now neutron is equal to 40 minus 20 is equal to 20. If you go for the calcium plus 2 ion, it is proton 20, electron 18 because it has already lost 2 electrons and neutron is 40 minus 20 is equal to 20. So now electronic configuration of calcium ion, I have not done for the calcium ion, calcium, I have done for this calcium ion, that is Ca plus 2, it will be 288. You can draw the orbital diagram now. Thank you for your patience hearing.